in the industry, especially now with the energy cost, any enhancement to the efficiency is always welcome. The iWAYS project came as a follow-up from a previous project called Etikina, where we demonstrated the value of the heat pipe technology to recover waste heat back to the plant and make it usable, and with direct saving on fuel consumption. iWAYS is more about utilizing that success and adding to it. This is really the biggest motivation I had when I basically thought of the idea for the condensing economizer. The challenges are always in the form of how reliable the data are from the plants. So in each plant, they would never have the same composition from their exhaust streams. And we have partners who actually helped us overcoming this challenge by very accurate measurements of the compositions of these exhausts. That input allowed me to design the heat exchanger properly, taking into account this very challenging composition. So that is also something that we had to work with the plant operators to find use of that heat in areas where we can actually have direct saving on the fuel that will not be used because we have that heat available. In addition, in the condensing economizer, we are actually condensing water from the exhaust stream, and that water is not pure. It does have condensates from acidic condensates, other contaminants that usually goes up in the stack. Now we are capturing them in a liquid form. The challenge is, how do you neutralize that flow and make that water usable again? And for this reason, we have very capable partners who have developed systems that can treat that water and neutralize it and make it usable again in the plant. The condenser economizer will recover up to 80%, even more, of that heat that was wasted without it. So really the biggest achievement is the reduction in carbon footprint. The second big achievement of the condenser economizer is recovering the water that would have been in vapor form going up the stack. When we condense, we have a solution. This solution has in it mainly water, but it does have also the acids that have condensed in the process. So when you have all these materials in a condensed form, you can actually treat them in a much more efficient way and try to recycle those materials back from that liquid solution rather than the gas solution. It is the best demo case that we can dream of for the condenser economizer because of the very challenging environment the condenser economizer will be working in. We are actually dealing with very harsh materials in the exhaust stream that require very careful selection of materials. We'll be aiming at recovering at least 30% of the total energy consumed. So we looked at very cost-effective design for it and demonstrated that for such harsh environment, we can actually do a modular, flexible design for the condenser economizer. Until now, condenser economizers from exhaust streams, they're not available. What we have demonstrated today is this is actually doable using what exists from materials point of view and from knowledge point of view. The heat pipes also bring many other advantages regarding safe of operation, multiple contingency, modular design, flexibility with regards to the geometry. We can now show the industry that, look, there is an answer here, and with this answer, with this system, what you see going up the chimneys into the atmosphere shouldn't. We can actually stop that, and that is water mainly that can be reused. The contaminants can then be treated safely, and the heat can be reused directly. So it's a win-win situation to everyone. So it gives the industry a much more control on the emission side. And I believe the chemical industry in particular will find very good use of the condenser economizer because it will add, in addition to the energy efficiency, water recycling, materials recovery. You can apply the same thing to any other industry, but you can see where the chemical industry in particular, because they are heavily regulated, they will benefit the most, I believe. The condenser economizer has been developed with factories with no chimneys in mind. What we have coming out of our factories is mainly oxygen and nitrogen, which is air. So my dream for the future factory is a factory where we can actually breathe the fumes coming out of it. There won't be any fumes. It will only be safe gases.